Everyone, you are welcome to another video. Today what we'll be looking at is question on machine. With this question is picked from WAEC 1999. So not to waste much of our time, let's quickly go to the solution one by one. Don't forget to like and share this video. Thank you. So the question goes thus: an inclined plane of angle 15 degree is used to raise a load of 4,500 meters through a height of 2 meters. If the plane is 75% efficient, calculate the velocity ratio and work done on the load. Don't forget, in my previous video I told you that we have three things that is very important in machine. You have the efficiency, the mechanical and fatigue, and the velocity ratio. So now we have, today they said to calculate velocity ratio and wood. And don't forget, we have different type of machine. We have lever, we have pulley, we have wheel and axles, we have pulleys. Then this is another type of machine, which is inclined plane. And how does this inclined plane work? Let me sketch this inclined plane. Ó dàbí pé kéèyàn fẹ́ gbé ẹrù láti ibi kékeré lọ sí ibi gíga. So assuming my load is here and I want to take my load from this horizontal ground to the upper height. Mo fẹ́ gbé ẹrù mi láti ibi kékeré lọ sí ibi gíga, and ẹrù yẹn wúwo láti gbé, so I will just need of a plane to carry the load from the lower end to the upper end, and that is what inclined plane means. Now let's go to the question again and bring out the parameters there. So they given us the angle plane of angle 15 degree. This is our theta. So our theta is given to us. Our theta is 15 degree. Then it's used to raise a load. Our load has been given to us 4,500 Newton through a height. They are giving us our height h to be 2 meters. Now let me quickly say something about this height. Don't forget, in my previous video I told you that velocity ratio is distance moved by the effort over distance moved by the load. That is, my velocity ratio is x over y. Our x is distance moved by the effort and our y is distance moved by the load. Now in this inclined plane, distance moved by the effort and the distance moved by the load. Distance moved by the effort, it is through this plane. This is distance moved by the effort. Almost about the length of the plane. Distance moved by the effort is always known as length of the plane, and distance moved by the load, only height bí kìíní yẹn ṣe ga sí, òun là ń pè ní distance moved by the load. So definitely this height is telling us that distance moved by the load. So we have to take note of that. So let's say that this is our y. Let's say that this is our what? Our y. Now let's go to that question. The question said that find the velocity ratio of the plane. Don't forget that the initial formula for velocity ratio is x over y. That is distance moved by the load, distance by the effort over distance moved by the load. But now we have another formula from inclined plane that we use to solve the velocity ratio, which is velocity ratio is 1 over sine theta. 1 over sine theta. So we have two velocity ratio for inclined plane. The first one is distance by the load over distance by the effort over distance by the load. The second one is 1 over sine theta, depending on how the question comes. In this our question 1 in form of degree, and we are going to make use of this velocity ratio. So for the first question now, velocity ratio is 1 over sine theta. So we now have velocity ratio is equal to 1 over sine 15 degree. So by pressing our calculator, 1 divided by sine 15. I'm coming. So we have 1 divided by sine 15. So I have 3.86. I have 3.86. This velocity ratio has no unit. And likewise, mechanical advantage has no unit. So now let's move forward. They are able to calculate the velocity ratio. Now going to the work done on the load. Don't forget, I told in my previous video that efficiency is work output divided by work input. Work output ní iṣẹ́ tí load ṣe tó gbé jáde. Work input ní iṣẹ́ táwa ṣe, that is the effort tá a ṣe sínú rẹ̀, that is work input. Work output ní iṣẹ́ táwa ṣe jáde, which is the load. The work input ní iṣẹ́ táwa ṣe sínú rẹ̀. So our efficiency is work output divided by work input multiplied by 100%. That is our efficiency. And don't forget this work output iṣẹ́ tá a gbé jáde, which is the load. Work input, it is what? Our effort. Now translating this one, work done on the load. Work done on the load. Iṣẹ́ tá a ṣe sórí load. Definitely that is our effort. That is work input. So definitely wọ́n gbọ́dọ̀ ti fún wa ní work output. Kí ni tẹ̀ ní work output? Iṣẹ́ tí load ṣe. From our knowledge of work, that is load of force times distance. And don't forget, they are talking about the load. Load is a force, and distance known by the load has been given to us. So now, and our efficiency has been given to us, which is 75%. That is 75 divided by 100. And our work output, iṣẹ́ tí a gbé jáde load ṣe, and that is 4,500 multiplied by distance known by the load divided by work output. Let's say our work output is X. There is no need for us to write 1,000% because our efficiency has also carry percentage. So now don't forget, how did you get this? It is for our concept of work, force time distance, which is load time distance moved by the load. So our load is 4,500, our distance moved by the load is 2. So divided by X, that is work input. This is also as work done on the load. So with this, you have 75 divided by 100 is equal to 4,500 times, so that is 9,000. That is 9,000. So divided by X. Now cross multiply. Now 75X is equal to 1,100 times 9,000. So our X is equal to 100 times 9,000 divided by 75. So we now press our calculator. So we have 100 times 9,000 then divided by 75, and I have 12,000 joules. So therefore work done on the load is 12,000 joules. So that is the solution to the question. So thank you very much for watching. Don't forget to like and share our video as we meet in the next video. Thank you very much.